Dear friends, welcome to VK lectures. Today we are going to study mathematical physics. So we are going to discuss today problems based on residues. Problems based on residues. So first question is f of z is equal to z divided by z minus 1 into z minus 2. Here this is a simple pole. Simple pole. So simple pole, here denominator is in the form of factors. If denominator is in the form of factors, simple pole solution we can write as, to find the residue at z is equal to 1 is equal to limit z tends to a, z minus a into f of z is the general equation. That means here z minus 1 into 1 divided by z minus 1 into z minus 2. So we got 1 by z minus 2. At z is equal to 1, we got answer as minus 1. At residue at z is equal to 2 is equivalent to limit z tends to a, two divided by z minus 1, or z divided by z minus 1 at z is equal to 2. That means 2 divided by 2 minus 1, that is equal to 2. So we got the residues for this simple pole at residue at z is equal to 1 as answer as minus 1, and residue at z is equal to 2 as 2. Then next question, again it is a simple pole where denominator is polynomial case. Question is f of z is equal to e raised to z divided by z square plus 1. Here z is equal to z square plus 1 is equating to 0. We got z is equal to plus or minus I. So we need to evaluate residues at z is equal to minus I and z is equal to plus I. So residue of f of z is equal to minus I is equal to e raised to z divided by 2z at z is equal to minus I is equivalent to e raised to minus I divided by minus 2I. Then residue of f of z is equal to I is equal to e raised to z divided by 2z at z is equal to I is equal to e raised to I divided by 2I. Next question, third question, f of z is equal to e raised to z divided by z raised to 4 minus 1. So when we are equating z raised to 4 minus 1 equal to 0, we got z raised to 4 is equal to 1, which means z is equal to plus or minus 1 and plus or minus I. So residue of f of z is equal to 1 equal to e raised to z divided by 4z cube at z is equal to 1 is equal to e by 4, and residue of f of z is equal to minus 1 is equal to e raised to minus 1 by 4. Then residue of f of z is equal to I is equal to e raised to I divided by 4I. Then residue of f of z is equal to minus I is equal to e raised to minus I divided by 4I. So residues have been evaluated. Then next question is f of z is equal to z square divided by z minus 1 whole square into z minus 2. So if we are equating the denominator as 0, we got z minus 2 is equal to 0, means z is equal to 2, and z minus 1 whole square is equal to z is equal to plus or minus 1. So for evaluating symbol pole residue at z is equal to 2, we can evaluate as residue at z is equal to 2 is equal to limit z tends to 2 z minus 2 into z square divided by z minus 1 whole square into z minus 2. So if we are cancelling, we got answer as 4. And for evaluating n is equal to 2 for residue at z is equal to 1, limit z tends to 1, d by dz of z minus 1 whole square into f of z. F of z is z square divided by z minus 1 whole square into z minus 2. So z minus 1 whole square and z minus 1 whole square gets cancelled. Then limit z tends to 1, d by dz of z square divided by z minus 2, that is equal to limit z tends to 1 z minus 2 into 2z minus z square divided by z minus 2 whole square. That means limit z tends to 1, 2z square minus 4z minus z square divided by z minus 2 whole square is equal to 2 minus 4 minus 1 divided by 1 minus 2 is equal to minus 3. So residue at z is equal to 1 is equal to minus 3. Next question, f of z is equal to 1 divided by z square plus a square. So if you are putting denominator is equal to 0, z square plus a square is equal to 0, which implies z square is equal to minus a square. So z is equal to plus or minus ia. So residue at z is equal to plus ia is equal to limit z tends to ia, z minus ia into 1 by z square plus a square into that means limit z tends to ia, z minus ia into 1 by z plus ia into z minus ia. Then we got 1 by 2ia. Then residue of z at minus ia is equal to limit z tends to minus ia, z plus ia into 1 by z plus ia into z minus ia. So we got 1 by minus 2ia. Then next question, f of z is equal to e raised to z divided by z raised to 4 minus 1. Singular points is z raised to 4 is equal to 1. So that is z is equal to plus or minus 1 and z is equal to plus or minus I. So residue at z is equal to plus 1 is equal to e raised to z divided by 4z cube is equal to e divided by 4. Then residue at z is equal to minus 1 is equal to e raised to minus 1 divided by minus 4. Then residue at z is equal to plus I is equal to e raised to I divided by minus 4i. Then residue at z is equal to minus I is equal to e raised to minus I divided by 4 of minus I cube is equal to e raised to minus I divided by 4i. Then next question, f of z is equal to z e raised to iz divided by z square plus a square. Here z square plus a square is equal to 0. Then it means z is equal to plus or minus ia. So residue at z is equal to plus ia is equal to z e raised to iz divided by 2z is equal to ia into e raised to I into ia divided by 2ia is equal to e raised to minus a divided by 2. Then residue at z is equal to minus ia is equal to minus ia into e raised to minus I into ia divided by 2 into I minus ia, that is equal to e raised to a divided by 2. Next question, f of z is equal to z e raised to z divided by z minus a whole cube. Then residue at, to find residue here, limit z tends to a, d square divided by dz square, z minus a whole cube, z e raised to z divided by z minus a whole cube. This and this gets cancelled, and we got d by dz of z e raised to z is z e raised to z plus e raised to z. Then d square divided by dz square of z e raised to z plus e raised to z is equal to z e raised to z plus e raised to z plus e raised to z. So residue at z is equal to a equal to a e raised to z plus 2 e raised to z. 1 by 2 into e raised to a e raised to a. No 1 by 2 is there. Sorry. A e raised to a plus 2 e raised to a, that is the answer, or e raised to a do 2 plus a. This is the answer for this question. Next question is f of z is equal to cot z. So we can rewritten this f of z as f of z is equal to cos z divided by sin z. Then we got the denominator as sin z is equal to 0, which means z is equal to n pi. So since this is a polynomial, there is a shortcut. If it is a polynomial and if it is a symbol pole, we can use this shortcut to find the singularity. Shortcut for finding the residue is numerator divided by derivative of denominator. Numerator divided by derivative of denominator. So in this case, residue at z is equal to n pi is equal to numerator is cos z, derivative of denominator is also cos z at z is equal to n pi is equal to 1. Now next question, f of z is equal to z square divided by z square minus 2z plus 2. So to find this residue points, z square minus 2z plus 2 is equal to 0. So minus b square so minus b plus or minus root of b square minus 4ac by 2a. So 2 plus or minus root of 4 minus 4 into 1 into 2 divided by 2a. So we got 2 plus or minus root of 4 minus 8 by 2. That is 2 plus or minus 1 by 2 by 2 is equal to 1 plus or minus I. So the roots are 1 plus I and 1 minus I. So residue of 1 plus I is equal to 1 plus I whole square divided by 2 into 1 plus I minus 2 is equal to 1 plus I whole square divided by 2 plus 2I minus 2, that is equal to 1 plus 2I minus I divided by 2I, and residue at minus I is equal to 1 minus I whole square divided by 2 into 1 minus I minus 2, that is equal to 1 minus 2I minus 1 divided by 2 minus 2I minus 2, that is equal to 1. This case also equal to. Next question, f of z is equal to 1 plus z square divided by z minus 1 whole square into z plus 2, and at z is equal to minus 2, residue at minus 2 is equal to limit z tends to minus 2 z plus 2 into 1 plus z square divided by z minus 1 whole square into z plus 2. So we got 1 minus 2 plus 4 divided by minus 2 minus 1 whole square, that is equal to 3 by 9 is equal to 1 by 3. Then residue at plus 1 is equal to limit z tends to 1 z minus 1 whole square d by dz of 1 plus z square divided by z plus 2 into z minus 1 whole square, that is equal to z plus 2 into 1 plus 2z minus 1 plus 2 plus z square divided by z plus 2 whole square. We got z square plus 4z plus 1 divided by z plus 2 whole square, it is equal to z plus 2 whole square divided by z plus 2 whole square is equal to 1. Now 12th question, f of z is equal to z sin z divided by z minus pi whole square. So here z is equal to pi, so residue is equal to 1 by 1 factorial limit z tends to pi d by dz z sin z. So we got limit z tends to pi z cos z plus sin z. So when applying pi, we got answer as minus pi. Next question, f of z is equal to a raised to I z plus cos z divided by z minus pi whole raised to 4. Z is equal to plus or minus z is equal to at pi. So we got residue at z is equal to pi is equal to 1 by 3 into 2 limit z tends to pi z minus pi whole raised to 4 divided by z minus pi d cube divided by dz cube e raised to iz plus cos z. So d by dz of e raised to iz plus cos z is equal to e raised to iz into I minus sin z. Then d square divided by dz square is equal to minus e raised to iz into I minus cos z. Then d cube divided by dz cube is equal to e raised to iz plus sin z. So we got residue at z is equal to pi equal to e raised to I pi by 6. So this is the questions with a residue, and in the next class we will study about complex integrations.